A block released from rest at position A slides with negligible friction down an inclined track around a vertical loop and then along a horizontal portion of the track as shown above. The block never leaves the track. After the block is released, in which of the following sequences of positions is the speed of the block ordered from fastest to slowest? Here the block is sliding from a height h. So at point A, the block has only gravitational potential energy. This numerical is based on the law of conservation of energy. So the initial energy must be equal to final energy. EF is equal to EI. So EI is equal to UG. That means MGH. Okay. Now, as the block reaches the point B, it is the lowermost point. At this point, it has only kinetic energy. That means the entire gravitational potential energy gets converted into kinetic energy. Okay, this is the lowermost point. So here, the speed will be highest. So that we will write here. So B, first one. Next, what happens? It goes to C. So when it goes to C, in between you are seeing another point E. Okay, this point is in between B and C. That means it has both gravitational potential energy and the kinetic energy. So more of the kinetic energy and less of the gravitational potential energy. Agree? Compared to C, it is at a lower height. Therefore, it has the more kinetic energy. So that one we will write. Then comparatively, next, this is a bit higher. No, so here the gravitational potential energy is a bit higher compared to E, and the kinetic energy is bit less. So C. When it comes to D, it is much higher but lower than A. So it has the lesser kinetic energy. That means half we can consider. Am I right? But less than C. The kinetic energy at point D is less than C. So only 4 positions he is asking. So check. So fastest to slowest. Here it has the highest speed. It has at D it has lowest speed. So where are the this one? Check B, E, C, D. So this is the answer. Okay, that's it. Hope this helps. Thank you. Bye bye.